Okay, one topic that is very current, very hot these days is all about nuclear reactors or nuclear energy or green energy. Nuclear energy is generated through nuclear reactors where chain reactions of fissionable materials are controlled and sustained. The heat generated in the reaction is made to boil water, and the steam produced turns turbines producing electricity. So basically, ang heat nga na-generate, ang energy niya nga dako kaayo, ipaboil sa water, producing steam, which will turn turbines, and these turbines will produce electricity. Now, there are 5 components in nuclear reactors. First, the fuel rod of fissionable material, control rod, of course, para makontrol ang fission, nuclear moderator, the reactor coolant para dili siya mainit paayo, and then the containment shell, so for protection, para safe. So this is roughly how nuclear reactors look like. So here we have, this is the reactor core, so this is where the fuel rod is placed, where the fissionable material is placed. So we have the reactor core here, so nana siya ang fuel rod, and then there's pressurized, the pressurized water is heated in the reactor core. So diha sa sulod nga naay fuel rod, naana siya control rod. So kaning nasa ibabaw mo ni siya control rod. Control rods are composed of materials that absorb neutrons. So para kadtong sa fission, para dili ang kadtong tanan neutron kay mohit og another fissile nga material, so naay control rod para mo absorb atong uban. So some control rods use cadmium or boron. So they regulate the influx of neutrons and to prevent the reactor core from overheating. Kay basig sobraan na pud ang fission, neutron mo igo og fissionable material, energy. So grabe nga energy, basig mo overheat. So there has to be a control rod. Also, there is a coolant. So the substance that transports heat generated by the nuclear chain reaction away from the reactor core. So kay na may heat, no? So para dili siya sobraan diri, maapil sa heat, so there has to be a coolant, constant supply of water para dili siya sobraan kainit. So when there is fission here, controlled fission reaction, so naray critical nga mass. So ang water is heated in the reactor core, and then this water, okay, ano siya diri, this very hot. So there is another container. So naay secondary nga coolant in the heat exchanger. So heat is transferred to the secondary coolant in the heat exchanger, generating steam. So kadong heat didto iya tong bukalon ang makapabukal siya sa water in the secondary coolant, producing steam. So ang steam modagan dito sa turbine. So the steam drives an electric generator creating electricity, and then so padung na siya dito. But then heat is transferred to an external source of water. So na siya steam diri, na pa diri na mo condense na siya. So condensing the secondary coolant, balik na sana siya dito, which is pumped back to the heat exchanger. Okay, so ang kanila pong steam, so this is the condenser. So there is also a moderator, aside from the primary coolant, the control rod, the fuel rod. So there is also the moderator, which slows down the neutrons to speeds of a few kilometers per second so that they can be captured more readily by the fissionable material. So modern reactors in the US exclusively use heavy water from rivers and streams or light water. That's why ang ilahang mga nuclear nga mga power plants are located beside rivers. Kay mo may ilahang source sa moderator. So ang moderator, ano to? Para mo slow down. So aside from the control rod, naapag yung moderator para controlled lang yun ang fission. Para sa pag-produce og clean nga energy. So Ang fuel rod nga gagamit is not actually a rod lang siya, nga fissionable material, but it actually looks like this, and then sudla na siya ani mga fuel nga pellet. So ingani ra na siya kagamay ang kanimura ni siya ang fissionable nga material. But this small fissionable material, one of this, so imagine also fuel bundle, daghan kayo na sila din ha, gipang suksok ng mga fuel pellets, mga fissionable material. So sa ingana siya kagamay class, that's equivalent to ang energy nga iyang ma-produce kay equivalent sa energy nga ma-produce sa 149 gallons of oil, or 1,780 pounds of coal, or 17,000 cubic feet of natural gas. So wala pa'y pollution. Ingana siya kagamay, dako na kayo ang energy nga ma-release. And there are no greenhouse gases produced here. So nindot yun siya actually. So we have a radioactive uranium, gamiton as a fissionable material, producing smaller elements, no, in the fission, and then free particles and heat. So muna siya gamiton, no? So in the power generation, ang kadtong spent nga waste after ni siya mo undergo fission, ang kadtong na spent nga waste kay cool siya na pool, ibutang siya og container, waste sealed in dry cases, and then ilubong na siya. So sa ubang lugar nga nay mga power plants, naagi na sila place kung asa ilubong ang mga spent nga waste. Now the problem here in the Philippines is I'm not sure, pero kung naaba sila giplano ani kung asa ilubong ang kanang mga spent nga waste if ever madayon ang power plant, nuclear nga power plant. So this is another picture showing us of the flow kung giunsa pag-generate, no, ang electricity. So ang condenser, so this is actually class a cooling tower. So ang cooling tower, hyperbolic cooling tower, ni-learn mo ani sa inyong pre-cal. So na siya, this is actually empty here. So nara na siyang tubig diri. And this is just hollow here. So diri this is entrance sa air para mo pa cool aning water diri para mo kuan din siya. So that's water vapor right there. And then we have nuclear fusion. The process, so baliktad sa fission, so kung fission buwag, si fusion combine. So the process of combining light nuclei into heavier ones is called nuclear fusion. So kung hinumdo mo sa katong graph, ano man to, no? So katong diri dapita nga mga elements sa mo undergo og fusion, katong mga gaan, lighter than the iron nga group. So this is accompanied by the conversion of mass into large amounts of energy. So same gihapon sa fission, nagyapoy energy nga ma-release. If i-compare na to ang fusion ug ang fusion is more appealing as an energy source. Ano man, because of the availability of light isotopes on Earth and because fusion products generally are not radioactive. Sa fission manggod, inig undergo niya og fission, ang spent nga waste ang mahabilin, it's still radioactive. But in fusion, available pa ang mga light nga isotopes, dali ra kayo, niya paggawan ang products pagid niya kay dili radioactive. But it is also known as a thermonuclear reaction. Nga naman, thermo meaning heat, diba? Because high temperatures and pressures are needed to overcome the electrostatic repulsion between two nuclei. So para, diba, mag-combine man sila, na-ay forces sa isa ka nucleus, na-ay forces sa isa ka nucleus nyo para mag-combine sila, kinahanglan to ma-overcome. And to overcome that, kinahanglan og high temperature and pressure. Now, the lowest temperature required for any fission is about 40 million Kelvin. And if you convert that to Celsius, it's still around 40 million degrees Celsius, diba? And imagine how hot that is. Init kaayo. Which is the temperature needed to fuse deuterium and tritium. So, unsa man sila mga isotope sa hydrogen. Gaan ra gid ni siya? Hydrogen 2 ug hydrogen 3. Lightest ni sila. And imagine 40 million degrees Celsius for these elements or isotopes nga pinakagaan. At present, scientists are still working hard to create the first ever nuclear fusion reactor. Sige pa sila experiment and they're still trying to, so naabot naman to sila atong plasma nga level, and they're expecting that maybe 2025 to complete the task. So kani siya, so fusion is actually mo'y energy. Most of the energy of the sun is created by the fusion of hydrogen. So deuterium, which is hydrogen 2, and tritium, they fuse together to form helium plus a neutron plus a big amount of energy. So inside the sun, the hydrogen atoms are heated so much they turn into a plasma state. So muna na sa scientist karon, so hot na ma-turn sila into a plasma state where electrons no longer orbit the protons in the atom's nuclei. And then, so because of that, kung plasma state na, the freed nuclei then fuse to form helium atoms and neutrons. And the fusion process unleashes vast bursts of energy. So, para ma-plasma state, kinahanglan gid siya very, very, very high nga temperature and pressure. So, muna ilang gi-work karon. So, this example is a comparison between fusion and fission. So, this is just like examples 1 and 2. So, gipa-calculate lang ang change in energy in corresponding to the given reaction. So, here we have the fusion of 2 deuterium atoms, nuclei, to form helium. And here we have the fission of uranium-235 to produce strontium-90, cesium-144, a neutron, and 4 beta nga mga particles. So, for fusion, we have the product, helium, nuclear mass of helium, minus, pareha raman ning duha ka hydrogen 2. So there is a change in mass of 0.02560 grams per 2 moles of H2. Duha man ka mole sa H2. And then for every 1 gram of reactant, so kung 1 gram of H2, that's 1 gram. So we know that for every 1 mole of H2, that's equivalent to 2.01355 grams H2. And then there is a change of 0.02560 grams of H2 for every 2 moles niya. So we'll get nga ang change in mass is 6.3569 times 10 to the negative 3 grams. So there is a discrepancy, meaning na release ng energy. So same po sa fission, you just subtract. So product minus reactant. So the sum of the nuclear mass of strontium-90 plus cesium-144 plus a mass of neutron plus 4 beta particles minus the nuclear mass of uranium-235. So we get there is a change of negative 0.21393 grams per 1 mole of uranium-235 undergoing fission. And then so to find the change in mass corresponding kung 1 gram ang reactant, so 1 gram of uranium-235, so 235 grams of uranium-235 equivalent to 1 mole, and for every 1 mole of uranium-235 na i-change nga negative 0.21393. So kung 1 gram kun of uranium-235 ang undergo fission, na i-change in mass nga negative 9.1034 times 10 to the negative 4. So asa may mas dako og change in mass ani? Ang kaning sa fusion, di ba? So, mas dako siya change in mass, mas dako ni siya energy nga ma-release di ay. So, next thing is to convert that into kilograms. So, we have i-divide na lang ni siya by 1,000 to find the number of kilograms, and then just multiply it to the speed of light raised to the power of 2. So, you'll be able to get your answer in joules, and then divide by 1,000 to get it in kilojoules. So, makita na to nga sa fusion ang na-release nga nga ano is kanang na 5.72 times 10 to the power of 8 kilojoules. And here it's 8.14 times 10 to the power of 7. So, mura ra siya gamay tan-awon, but we have to take note that the unit is in kilojoules. So, dako gina siya ang difference sa ilahang energy. And, dako ang energy nga release sa fusion.